$100 billion. That is roughly what a single one of the largest AI data centers now on the drawing board is expected to cost by the time it is finished. Not the company that owns it. Not its whole global network. One campus of buildings in one location. $100 billion is more than the entire annual budget of most countries on Earth. So it is worth asking a simple question that almost nobody stops to ask. What does a place like that actually do all day? What are you paying $100 billion for? From the outside, the answer is disappointing. An AI data center looks like nothing. A cluster of huge, windowless, gray boxes, usually somewhere with cheap land and cheap power, ringed by fences and fat electrical lines. There are almost no people. You could drive past one and assume it was a distribution warehouse. But inside those blank walls sits possibly the most concentrated pile of computing power and electricity ever assembled, and it is running flat out day and night. Walk inside and the disappointment turns into something like awe. Row after row after row of identical metal racks, stretching farther than you can see, each one packed with computers. But these are not the computers on your desk. The thing doing the real work here has a specific name, and the entire AI boom runs on it, the GPU. GPU stands for Graphics Processing Unit, and the name is now a historical accident. These chips were invented to draw video game graphics, because painting a screen full of pixels means doing thousands of small math problems at the exact same instant. It turns out the math behind AI running a giant model is the same shape, thousands upon thousands of simple multiplications all at once. So the chip built to render explosions in games became the chip that runs artificial intelligence. A single one of the good ones costs more than a car. And a data center like this does not have one or 100. It has tens of thousands of them, sometimes hundreds of thousands, wired together to act as one enormous brain. That is where a huge slice of the $100 billion goes, not into the building, into the chips inside it. Row after row of processors that each cost as much as a car, running 24 hours a day. So what are they all doing? Turns out the day splits into two completely different jobs. Every AI data center is doing one of two things at any moment, and they could not be more different. The first job is called training. The second is called inference. Training is how you build the model in the first place. Inference is what happens every time you actually use it. Understanding the gap between those two words is the key to understanding this whole industry, so let us take them one at a time. Training first. This is the big, dramatic, expensive one. To train a large AI model, you take an almost unimaginable amount of text and images, a big chunk of the public internet, and you feed it through the model over and over millions of times. Each pass, the model nudges billions of internal numbers a hair in a better direction, slowly getting better at predicting what comes next. It is less like writing a program and more like sanding a sculpture with billions of tiny strokes. And this takes staggering resources. A single training run for a frontier model can occupy tens of thousands of those GPUs, running continuously, for weeks or months without stopping. If one chip fails in the middle, which happens constantly at that scale, the whole run can stumble and have to recover. This is the part that costs a fortune in electricity and hardware for one model. When you hear that a new AI model cost hundreds of millions to make, this is where the money went, months of a 100,000 chip machine grinding through the internet. There is a subtler reason a training run needs its chips in the same building, and it is worth a moment because it explains the architecture. During training, those tens of thousands of GPUs are not working on separate problems. They are all working on the same model at the same time, which means they have to constantly compare notes, shipping huge amounts of data back and forth between one another thousands of times a second. If the chips are even slightly too far apart, that conversation slows down and the whole machine stalls waiting on itself. So the chips are packed tight and wired together with specialized high-speed networking that can cost as much as the chips it connects. A training cluster is not a pile of computers. It is one computer spread across a room, pretending to be a single brain. But here is the thing most people miss. Training a model happens a handful of times. You build it and then you are done until the next version. Inference, the second job, happens every single time anyone, anywhere, uses that model. And that is not thousands of times a day. It is billions. Inference is the actual using of the model. You type a question into a chatbot and hit enter. That request flies to one of these data centers. A slice of those GPUs lights up, runs your words through the finished model exactly once, produces an answer and sends it back all in about a second. Multiply that by every person using every AI product on Earth at the same moment, and you have inference. Any single answer is cheap. The sheer volume is what now eats the majority of the world's AI computing power. Which brings us to the resource nobody expected to be the bottleneck: electricity. All those chips, running all day, turn nearly all the power they draw into heat and computation. A large AI data center can pull as much electricity as a small city, hundreds of megawatts, continuously without a break. This is not a rounding error on the power grid anymore. It is the reason tech companies are now signing deals for their own power plants, including nuclear ones, just to keep the lights on inside a single building. And all that electricity becomes heat, which is the data center's second great enemy. Pack 100,000 chips into a building and they will cook themselves in minutes if you do nothing. So a huge part of the facility and a huge part of that $100 billion bill is not computing at all. It is cooling. Enormous fans, chilled water piped directly to the chips, sometimes whole facilities built where the climate is cold or the water is plentiful. A meaningful chunk of the energy goes just to carrying heat away. Add it up and a picture emerges of what $100 billion actually buys. It buys tens of thousands of specialized chips. It buys the power contract to run them. It buys the elaborate machinery to keep them from melting. And it buys the building, the networking, and the backup systems that keep all of it running without a hiccup. The computing is the point, but a startling share of the money and the energy goes to feeding and cooling the machine rather than to the thinking itself. And notice what is almost absent from all of this. People. A facility representing $100 billion of investment might be run day to day by a few dozen technicians. The real work is done by the machines. The humans are there to swap failed hardware, watch the temperatures, and keep the power flowing. This is one of the strangest features of the AI economy. Enormous capital, enormous energy, and almost no labor inside the building. So the next time you hear that a company is spending $100 billion on AI, you know what that sentence actually means. It means a windowless building somewhere, filled with hundreds of thousands of the world's most expensive chips, drawing the power of a city, bleeding heat into cooling towers, training a model for months and then answering the world's questions billions of times a day, tended by a skeleton crew of humans. That is the physical reality underneath the chat box on your screen. The short version. An AI data center does two jobs. It trains models rarely and expensively, and it runs them constantly and at massive scale. The $100 billion price tag is mostly chips, power, and cooling, not software and not people. The intelligence feels weightless when it answers you in a second. It is not. It sits on top of one of the most physical, power-hungry, capital-heavy machines humanity has ever built. Next time, we are going to zoom all the way in on the chip at the center of all of it. What a GPU actually does that your laptop cannot, and why one company ended up owning the entire boom. Subscribe and we will keep